deliver some of the material that we actually have the same interest in, which is optimization. And because this class itself is more likely more advanced, because I'm sure some of you are actually a graduate student, yes, not undergraduate. So probably for the basic idea itself, what is optimization, what is linear programming, and etc., you also already know. So I will basically get into the topic directly. Okay, so one of my specialty in optimization itself is regarding how we can apply it in humanitarian logistics. So the basic idea of humanitarian itself is slightly different with whenever we say we talk about the commercial logistics. Of course, the core is still the same. Okay, so for example, whenever we try to find out the location for the facility, and or we try to develop a distribution system, the idea or the basic model that we use is actually quite the same. So if I will already talk about some of these, probably kind of like distribution and or optimization, then I'm sure you probably already can grasp the idea behind it. And one of my work during my PhD is actually entitled this. So I try to develop a model that incorporate a multimodality in order to distribute the relief goods for the disaster response operation. And yeah, I will already talk about myself. So maybe if you are interested in this topic, you can also try to check my name in the Google Scholar, and then try to find some of the journal that I already wrote with my advisor, and also my current research topic. Okay, so this gonna be the basic idea of what is humanitarian relief operation. Okay, so I think the Philippines and Indonesia is kind of share the same what geographical location. So whenever we talk about disaster and all humanitarian operation, we actually have the same, what I think, kind of like risk and hazard, although probably slightly different. Yeah, so we are located in the Ring of Fires. Obviously, you have a lot of volcanoes, so does Indonesia, and then we also have the risk, quite high risk regarding, for example, the earthquake. Okay, so whenever a disaster happens, so there's actually quite a level whenever we call for, okay, it's actually a disaster or an international disasters, is depend on how many victim or how big the emergency or disaster are. So whenever for example, whenever a region cannot handle such emergency, then they will call the national, and if national cannot handle the scale of the emergency or disaster, then we will basically ask for international help, international donation. So the basic idea for the humanitarian relief operations actually start from the main hub in internationally. So we are dealing probably with some donation from abroad, and if that's what happened, then the nation or the country needs to have a specific port of entry in order to receive those relief goods sent by the neighboring country or other organizations abroad or international organization. And once the goods is being received by the country, then they will kind of short it and then send it to regional hub. Okay, because there are probably several port of entries, and particularly whenever we talk about Indonesian, then there are probably a lot of port of entries, or not only one, but if we talk about the case in Nepal, for example, they only have one port of entry, but then they will need to send it to regional hub depending on in which location or which region the disaster actually happened, and then they will send the goods to the local depot before on the last mile. Basically, they will send it to the beneficiaries. Okay, the settlement, the beneficiaries, and one of the most cited actually the journal regarding the humanitarian relief and how this concept is being built is actually, you can check in the Bauchik and Bimun from 2008, and how the flow of this humanitarian relief operation is actually happened. Of course, these flow probably differ from one country to another, and a different, for example, scale of disaster will also impact it in how the relief goods gonna happen. So, for example, 2 months ago, several months ago, there is an earthquake in one of region in West Java, and because our country is still able to cope with the situation, we basically not ask the international help, and so uh, uh, the flow of the goods start from the regional hub rather than from the international. So it really again depends on how the disaster or the scale of the disaster will impact to this relief operation. Okay, now the question will be why we need a humanitarian logistic. Okay, so we know that in commercial logistic, the function of logistician is really important. Why? Because, well, I think up until 15% of the good cost is actually come from distributions itself. Okay, so how we build the facility, how we choose the facility, how we distribute the good, it's actually giving a lot of cost to the goods. Okay, so especially if you are working in a service type of, for example, three party logistic company, four party logistic company, then obviously having a good logistic system will be beneficial for your company. Okay, in disaster context itself, we try, the government, the decision maker basically try to deliver the good as soon as possible so that the beneficiary will suffer less. Okay, what does it mean with suffer less? Okay, so whenever we have a disaster, regardless the scope, then they will have a less cope or less how to say that, they will have a difficulty on their livelihood. Probably their house is breakdown, they cannot stay in their house because it's too difficult, it's too dangerous, they will need to evacuate, they cannot work, and so a lot of goods will be need to be sent to them in order for them to continue their livelihood, so they can eat, so they can still, for example, like stay alive. Okay, so in regards with the condition, yeah, the health condition. Okay, so the function of these people, so-called logisticians, is can be a really vital. Okay, so whenever we say about relief goods, it can be also the food, it can be also the medicine. So if the company, sorry, if a region probably have an immense number of victims, then they will need more stock on their medication and medicine, including how the government will need to assign some of the human resource too, including the volunteer, probably the military to help, and etc. Okay, so if we don't consider the so-called humanitarian logistic during disaster response, then the flow of the goods, the flow of the human itself, or the human resource cannot be executed well, and then we might prolong the suffering of these victims. Okay, I want to talk about a bit about how Indonesia maintained or our coordination system. So to give you more, how to say that, a few, I think, before we go directly to the case itself. Okay, so whenever there is a disaster, there a region or a province usually will have the so-called fast response team that is created by we call it BPBD, which is the National Disaster Agency in the region, in regional. And then they will also create the incident command, ask someone with the high experience to become the head of the command, ask the mayor to help. And if they need to escalate the problem, then the mayor will contact the governor, and the bigger the scale of the disaster, then they will basically escalate it up to the ministries and also president. Okay, so about the BPBD here, sorry. How can I? Okay, so about the BPBD, we have BNPB, which is the National Disaster Agency. Okay, and whenever we have a real big scale of disaster, they will basically create the coordinator center that also will coordinate with the militaries that we have, the Indonesian, and also any organization, NGO, and others such as Red Cross or the United Nations, and also some of the bilateral international cooperation from other countries. And they will deploy military and the search and rescue team to basically coordinate with incident command to do the fast response as soon as possible. So the fast response team usually will help with kind of like they will be deployed in order for them to check the scale of the disaster and to basically estimate the number of the victims and in which area they will need to be responded as soon as possible. Okay, so we basically have decentralization system. So this coordination will happen if the scale of disaster is big. So how if the scale of emergency or disaster itself is acceptable or in regional level? So basically we will just following this. So we will have BPPD in district level. If they can handle it, then they will not escalate it. If they cannot handle it, then they will escalate it to regional level until the national level. And if it's possible, so for example, if it's necessary, so for example, the tsunami in 2004 or the earthquake, big earthquake in Yogyakarta in 2010, they basically directly ask for international help. Okay, so the multi-stakeholder platform is basically how we can incorporate all of the actors or organization that is as much as possible. So this decentralization system in Indonesia itself also help how each of these government institutions regarding this disaster can have their own cooperation with other stakeholders. So for example, for Yogyakarta, we have a coordination with United Nations directly, although the national level also have their coordination directly with the United Nations. But if some of the district level or regional level doesn't have any cooperation, it's also okay because the national level can still help. Okay, so this is actually the foundation that is being used in disaster management plan in Indonesia. Probably the Philippines also have almost the same, I think. Okay, so we basically use a lot of Sendai framework for DRR or disaster risk reduction because this is the newest. Since the Great East earthquake and tsunami in 2011, then the Japan and other country decided to develop the DRR. And then under that, we also have several legal foundations to ensure that all of the national development plan regarding the disaster is basically work based on what is being regulated. Okay, so uh, currently Indonesia has these policy directions, so the advancement of disaster resilience, and because we try to also achieve SDGs, so they also try to maintain the sustainable welfare for sustainable development. So it means that, yeah, basically it's gonna be a tough action, I think, because we are dealing with quite frequent disaster each year. Okay, so last year itself, there are plenty of earthquakes and flooding and eruption in Indonesia, and each of the disaster agency try to help as much as possible, and then try to at the end we also try to build back better and ensure that all of the victims, all of the beneficiaries during this disaster can still attain the sustainable welfare. Okay, so I will basically skip this. So I think it's also important that this pentahelix governance and collaboration should be used whenever we try to make disaster action plan, because academia itself basically probably only have the knowledge. So whenever I talk, probably today when I say to you, okay, we can model it like this, then probably we also have several assumptions behind it, right? So we can give some of our expertise. If we model it like this, or if we simulate it like this, then probably some of our recommendation will be A, B, C, and so on. And the community as the I think the entity, the biggest and most important entities, also have to understand how dangerous a disaster can be, because some of these people probably, okay, so for example, so Indonesia have a high risk, however they have a low vulnerability level, okay, or high vulnerability level. So it means we have a high risk, but we are vulnerable because some of the factor itself is how the community perceive all of this danger. In case of the volcanoes, for example, the area near the volcanoes is actually the most suitable place to plant their to have farming, for example, and or planting some of veggies. And so some of this community think that if they leave this area, then their livelihood will be gone. But then if they still stay in those particular danger zone, then actually it's also have a higher risk to their livelihood and so on. And the other collaboration that is also needed, of course, the government, because like I mentioned before, in Indonesia, the disaster agency is the one that always make the incident command and will deploy the fast response team before they escalate the problem. And of course, we also need the help from the businesses due to the sustainability for the welfare goals. And the last one is the media. So the media should be able to help spreading the news, the information that is as reliable as possible, without creating a buzz or without making the community to become a panic and so on. Okay, now let's go back to what is why we need the humanitarian logistic. Okay, so in disaster itself, what we need is actually a lot. Okay, so we need the relief good, we need the medical and healthcare service, then we need the evacuation system, we need to have a good shelter, and this good shelter will be able to be achieved if they have also a good sanitation. So of course, whenever an emergency or disaster happen, there's gonna be a fatalities, probably victims, dead body, injured people, some population displacement. Okay, so for example, whenever we heard about war in some places, then they will need to evacuate somewhere, or if there is an eruption, those location danger zone cannot be used, and so on. And what I explained at the beginning, then there will be a daily need shortage. They cannot continue with livelihood. So, and some of the businesses is also probably cannot be running due to the disaster itself. And of course, the bigger the disaster, then the higher possibility that the whole infrastructure is going to break down. So it can be the road, it can be the railway, probably the airport itself cannot be used due to what maybe the landslide and so on. And at the beginning, the incident command will make the public warning. Usually if it's a slow onset disaster, such as the what probably like volcano, for example, the sign, so that the as the response, the government or a related agency can make the public warning. And if it's a fast onset disaster, such as a landslide or an earthquake, for example, the first response operation is including the search and rescue and also emergency operations, so including dealing with the medical and healthcare service, ensure that this population will be moved or evacuated, and also basically try to deliver all of the need or goods that is being need or relief goods. So again, we try to reduce the suffering of these people as much as possible. Okay, so we basically try to distribute the goods to ensure that these goods can be used by all of the victims or beneficiaries until they can sustain by themselves. Okay, what does it mean by sustain by itself? It means that, okay, the risk of the hazard is gone already, and probably if their house is not that broken, then they basically fix it. If they need to move to other places, such as the example due to Fukushima explosion, they will need to be evacuated from the affected area. The government or the disaster agency still have this kind of homework or task to ensure that until they can sustain themselves, they still need to be given with the relief goods. Okay, so whenever we have the disaster, okay, the government probably will set up a humanitarian staging area, okay, whenever even if they receive the international or global donation, which is sometimes it's the same with the port of entry. And then in the regional level, they will make or create some logistic operational area, and then they will send it basically to the affected prefecture or affected region. It depends. And then from there on, then they can try to develop the so-called last mile distribution system. Okay. Some of the problem actually happened in each of these locations. So for example, in humanitarian staging area or the port of entry, sometimes we receive enormous number of the supply or the relief goods, and it's sometimes unmanageable. Okay. However, in the affected prefecture or region, most of the time the infrastructure is breakdown. There are lots of victims and lots of disruption. Okay, and from the at the beginning, so from the humanitarian staging area until it being received by the beneficiaries, then we basically have limited information. And sometimes there is the lack understanding of the local and regional capacities. What does it mean with capacity? Because for example, if you don't know how many railway, for example, or which route is accessible, and whether or not the airport can be used, then you are kind of like understanding of these regional capacities. Okay, so that's why it's really important to deploy the fast response team first to basically kind of scanning and then understand the whole situation and then give these information to the related agency so that they can prepare and they can plan how these relief goods can be sent from the so-called humanitarian staging area to basically the local distribution center and then being received by these beneficiaries. So with those several problems, there is basically a necessity for basically developing response plan, let alone the local level, or regional level, or national level, basically based on the capacities on hand. So we will use the concept of humanitarian logistics to basically responding to the disaster and mobilizing people, resources, skill, and knowledge. Okay, and we need to ensure that it should match with the capacities that is being owned by the government. Okay, so this is some of the example how a really big disaster can basically create a lot of destruction. Yeah, so in the left hand, it's actually the Sendai Airport breakdown after the Great East earthquake in 2011, and on the right side is actually the impact of the tsunami. You cannot basically access most of this location due to the scale of the disaster itself. And so I can say that infrastructure breakdown are not uncommon. So it's common. For example, if I'm not mistaken, 2018, there is a really big earthquake and some scale of tsunami in Celebes Island in Sulawesi, where some of the area is actually having also a road breakdown. Okay, in case of Yogyakarta earthquake in 2006, for example, the airport cannot be used because the ground it's actually broke into two, and they need to repair it as soon as possible in order for them to receive some of the relief goods through the air. Yeah, and the job for humanitarian logisticians at this point is we need to ensure that we can still mobilize the people, the relief good, even when the key resources are destroyed, the road, probably railway or airport, or maybe port, we don't know. And to do that, then we can come out with an idea of the multimodality or the transportation mode combination. So this is one of the part of my dissertation where we try to ensure that the relief goods must be sent in the right time, and then we still need to ensure the best value for money. Okay, so there are several challenges, of course, because we are talking about humanitarian, we are talking about things that is uncertain. Okay, so that's the biggest difference between commercial, logistic, and humanitarian, is that in commercial logistic, obviously you have some up and down. However, you have a historical data for you to say, okay, we can send this much goods, or we can use this road, because the uncertainty is happened, but it's limited. Whenever we talk about humanitarian logistic, we are not only talking about the big number or the scale. We are not only talking about the infrastructure breakdown, but we are also talking about a high number of uncertainty. So according to a study by Xu and Pant, we are dealing with the so-called time varying supply and demand. It means that the number of the goods that is being received by us from the donation, from the the inventory of the government will depends on the timing, or each period will be different, and the demand is also can be really different from one point or one period to another, because at the beginning probably the response team calculated wrong, so the demand is that is being recorded is probably, for example, alpha, and as time pass, probably more people needs to be evacuated, needs to be given relief skills, so that the demand probably also increasing. And once these victims try to settle down after, for example, age plus something period, then probably both supply and demand will be decreasing over time. So we do have a lot of uncertainty, but the problem is we don't know how much. Okay, so we don't particularly we don't have much probability. We or the historical data on well, more or less this number. If your country have a really good database system, then probably it's way easier to actually recalculate things. However, for example, in Indonesia, the data system itself sometimes it's not the most updated one. So whenever we try to do the fast response calculation, then probably there's gonna be miss in or a high number of deviation. So it's actually quite common during disaster. So due to these challenges, the objective of this research is to conduct, first, we try to understand the capacity assessment first. Okay, so it should be deal prior or before the disaster. Then, based on those capacity assessment, we can create several scenarios based on the scale of the disaster, for example, the probability of the scale of the disaster, and we can basically either develop the regional relief distribution system deterministically, or we can try to develop this regional relief distribution system using several scenarios. Or if basically you have a certain probability value that you can get, then we can later solve it using stochastic programming. Again, it really depends on which approach you want to do. Then probably later Pak Wira will explain more if there are time regarding how you can deal with stochasticity or uncertainty. Okay, so to basically solve this so-called multimodality or multimodal distribution model, then we can create several nodes. Okay, so as I mentioned at the beginning, we will have the so-called port of entry, and I will call it from now on as the supply node. There are probably several number of supply node, I number. Then we will have the regional hub, which from now on I will call as LOA or logistic operational area. And we might also have several affected area. Okay. We basically in Indonesia itself, in Java Island, we have several number of transport mode. We can use all. Okay, so we have airplane, we can use helicopter from the military and media. We have road transport, actually using truck. We are less likely to use the trailer due to the capability or capacity of the road itself. And then there is the needs, or there is a vessel too. We can use some vessel, and we also have railway. So these five types of transport mode can be used to send all of these relief goods from subline to LOA and from LOA to the affected area. Okay, so is it possible to send it from subline to affected area? Yes, of course, but I want to create a model with 2 levels first, and then probably later on I also will consider we also can consider the direct supply. Okay, so this is a bit mathematics. However, this is how we can try to develop the mathematical model. So basically, this is kind of like two level of transportation model. So if you are familiar with transportation model, usually we have supply node and then customer or consumer node, and then basically how much we should send it, right? But then in my case, there is two level, okay? So I need to think about how much should I send to the LOA from the supply node, and then how much should I send to the LOA to the affected area. But then I also then increase the problem because we have multimodal. So it's not only how much should I send, but how much and what transport mode should I use to send the goods. Yeah. So whenever you try to develop the model, you can use the simplest model and then add more constraint as you want. Okay, depending on the complexity of the model itself and how much you try to incorporate the kind of like the reality or the actual constraint in a real life to your model. Okay, so because I also want to capture the uncertainty due to the varying supply and demand. I decided to cut some of these decision into different period of time. So I have the set of time period, but then for each time period that I have, I also will cut it into the micro periods so that because whenever we talk about the multimodal, obviously truck and, for example, airplane will have different capacity, but they also have a different travel time. And why I have the micro period here, the tau, is to ensure that, okay, so whenever the truck, okay, for example, if the truck needs 6 hours, then probably airplane only needs 1.5 hours, and etc. And then we know that which mode should we use in order for us to deliver the good as much as fast, but also as still have the monetary value as possible. So we are not gonna send a lot of airplane once, probably because the capacity also, but we also need to think about the cost. Okay, so each of these vehicle will have their own cost, and there's also the maximum number of vehicle for each mode. And then each facility, each node will also have different capacity, because, for example, the old airport in Yogyakarta actually only have one runway, and then they will need a lot of waiting time to actually have takeoff and landing. Although currently we have a bigger airport, so that they can receive more airplane at the same time. However, we still need to also consider those capacity, so that we know which mode is the best. Okay, and then we have several decision variable, including like the node choice first, so which logistic operational node should be chosen, and then how much also should be sent, and in which mode should the relief good is being sent. Of course, whenever we develop the model, we will have several assumptions. We will also, not this, we will also need to add some limitation. So for example, in this case, before I developed the model, prior to that, I did the preliminary study to check the LOA and supply node if we have a certain affected area. So if I have a certain area, for example, in Yogyakarta, currently I live in Yogyakarta, then the possible LOA and possible supply node is actually will be different whenever uh, with if I have the disaster or the affected area is located, for example, in Bali or in Sumatra or in Kalimantan or in other. Okay, so because I have this preliminary, I assume that this is all known. We all already have these preliminary studies, and then I also have the assumption. We also basically develop the assumption that all the links and the availability status, so whether it and the node, whether it can be used, whether the road is broken, whether the railway can be used, whether the airport can be used, and etc., can be obtained during the first period of the disaster strike. So it means that the fast response teams needs to do the scanning and give the availability status and the broken not broken status to the logistician, and then the update link and nodes availability information for each period is known a priori. So we also assume that okay, after a certain period, then it should be able it should be fixed already, so that for example, if in the period 1 and 2 the airport is still broken, then at maximum 2 period the airport should already be able to be used, and etc. Okay, and the mode of transportation used are 5. There are 5, including truck, train, vessel, airplane, and helicopter. And for each mode of transportation, we only consider one type. Okay, so for example, the truck will be 3 ton, and all of the truck that is being used in my case will have the capacity of 3 ton and so on. Okay, the total supply available in each node supply is different. It really depends on how much donation is being received for these for each supply nodes, and the demand needed at the affected area will be also depend on the number of the affected people. Okay, so that's the job for the fast response team. And we also allow the vehicle to have multi-trips. So in some of the cases that we have, once the vehicle delivered the goods, we are not consider them to go back to the original node and then send it again. However, in my case, each vehicle will have multi-trips, and it can be we only consider 1 working period, and the logistic operational area and the affected area can only be served using the resource status in each period. Okay, and the maximum number of available vehicle is determined per node. Okay, so that's the importance of having to do the preliminary study, including understand your logistic, your possible LOA, your possible supply net, and also the number of available vehicles. Okay, so the multi-trip consideration kind of will look like this. Okay, so for example, if vehicle 1 for the round trip case took 4 hours. Okay, so then it means in each period they actually can back and forth several times. Okay, and so in this case, each period is actually I created to be 3 days, and the micro period I basically cut it in hourly base. Okay, so for example, each period will have 72 hours, and then basically as long as the vehicle is still able, so we don't consider the driver working hour, basically each vehicle will be able to do several number of trips within 1 period. Okay, some vehicle might not be able to do that due to, for example, if I use the vessel, it might need several days to actually being received. Then if that's what happened, then we can basically how to say that, a prolong the period, so they will pass a certain period, but then the calculation for the travel time will be dependent on the micro period. Okay. And from that assumption, we develop the model first. Well, it's kind of like whenever you have the linear programming. So if you already know your decision variable, then basically we can try to create the objective function, then we will create the constraint, right? So my objective function itself is I divided into two periods. Sorry, two parts actually. The first part, I will call it as the initial period. It starts from whenever the disaster happened until the government say, okay, the initial period is stopped, and then we will do the second part, which is the period of the initial plus one until the end of the continuum period. We try to basically ensure that before the after the age continuum finish, all of the victims beneficiary can sustain themselves. Okay. The in the initial period, basically we try to find out the minimizing the delivery time. Okay, so we calculate basically how much that is needing that good that needs to be sent and multiply it with the traveling time rather than the cost itself, because during the initial time it's actually the most critical one. We don't really care about the cost. We only care about how we can reach or send the goods to the beneficiary as fast as possible. However, obviously after a certain we call it kind of like emergency time, then the government still need to sustain or send the relief good to the beneficiaries, but they still need to consider the cost. Because for example, if you use the airplane, obviously you can deliver as much as possible, as fast as possible, but then it will give you a higher cost compared to if you decided to just utilizing even more truck, you actually can reduce the cost. So at the beginning, the government will try to minimize the delivery time, and after a certain period, they will try to minimizing the total cost rather than minimizing the delivery time. And this is actually the result from the interview that I did with the disaster agency, and on how much and how the objective is actually changed after a certain period of time, because they cannot just send the good all the time with the airplane, and it will cost much more compared if they send it using truck, okay, or vessel. Okay, so we will have several constraints, including the flow conservation constraint, and that we need to ensure that the goods must be that is being sent must be less or equal to the available supply. And then each node will have the capacity, and then we don't consider the unmet demand. Okay, so we try to ensure that demand is met. If it's not met, then it's still okay, because some it can happen. So the constraint six can happen during the very first initial solution due to limited supply. And then we also need to ensure that we still comply with the maximum number of the vehicle. And then we will need several other constraints, including the node availability constraint, such as in equation 11 and 12. So if the node availability is 0, you cannot basically use the node. If it's equal to 1, you can use the node. So it depends on whether this node can be used or not, and it will change over the time. So we have the period also notation, and we also have the constraint for decision variable. Okay, so this is actually the result for my preliminary study regarding the capacity assessment. So we're focusing on this logistic capacity assessment in order for us to find which node is acceptable for to become either as the supply node, where the port of entry, and also which node can be used for the LOA or logistic operational hub or area. Okay, so some of these nodes, so the one that is supply node is the province that have a really big airport and have a high number or frequency of international flight. It means it's way easier for the international donation to come and help whenever we have such a supply node, because they already understand how these donation from international needs to be taken care of or managed. And the choice of the logistic operational hub, so this is the case in Java Island, yes, is based on the location that have either airport, a port, or railway that will and road that connect all of this location, particularly from the supply node. Okay, so this is important. Okay, so then after we select some of these nodes, we can check their connectivity. Okay, so you can check each connectivity based on the modes itself. So for example, for figure 5, we have the network for airlift or air transportation. Okay, and basically we can see how the Jakarta, Surabaya, and Bali here have a high frequency and have high connectivity to a lot of this node. Okay, and it's also match with how the preliminary happened and how Jakarta, Surabaya, and Bali is suitable as the supply node. Okay, for the sea lift itself, it's actually quite limited. Okay, so some of this area have the port, but the biggest one is actually in Jakarta, Semarang, and Surabaya. There are some small port that also can be used, although not specifically commercial, such as Pangandaran, Cirebon, and Cilacap, but they do have port. So we also can consider that they will have different capacity, of course, because probably the superstructure is not as advanced as the one in Jakarta or Semarang or Surabaya. Okay, then once we develop that, we can try to make the so-called logistic capacity assessment from the choice of the port of entry or supply nodes, and also the logistic operational expedition. Okay, so we will need to create the so-called main location and also alternative location. What if the port of entry cannot be used? What will be our alternative solution? Which port can be used or which airport can be kind of used? Yeah, if you have no alternative location, it's also okay, because it's really possible. Okay, this is the plan that we build. Then in the logistic operational area itself, we also again consider which airport can be used, which port can be used. If you have the railway, then probably you also will need to put it here. Yeah. So, and the consolidation area will be the port or airport in the affected region itself. So we don't know yet which one, but then we basically developing this specifically for Java Island. Okay. And I will use the case in 2006, an earthquake that happened in Yogyakarta province. And we developed this scenario together with the Provincial Disaster Agency or the Regional Disaster Agency of Yogyakarta. And based on the data that happened in 2006, actually, the airport cannot be used. The railway also cannot be used. So it can be our starting point on how we develop some of the scenario. In this case, I only have one scenario based on the earthquake that had happened. Some of the other study, geographical things, geologic also, basically they also will have their own study, and then we actually can do some multidisciplinary study with them, and developing a different scenario is possible. Okay, so because we do have some of the parameters that we will need to run the program. Basically, in this case, what is uncertain is the supply, the relief demand, and the number of vehicle itself. Okay, so the more period you have, obviously you can gather more supply. But then after the initial period has passed, then obviously the demand, the supply, and the needs for vehicle will be decreased over the time. Okay, so this is basically the time varying demand and transport availability based on the Yogyakarta earthquake scenario, the previous one. While other is actually still deterministic, still static, yeah, not dynamic. Okay. So from the mathematical program mathematical model that I have, we try to run it based on some of those varying data, uncertain data, and then we have basically from the logistic capacity assessment, because we select Yogyakarta as the affected area, we take it out from the LOA node. Then we still choose Jakarta, Surabaya, and Bali as the supply node. And then we choose other possible or alternative LOA, including Tasik, Cirebon, Cilacap, Surakarta, Semarang, Magetan, and Malang, before sending it to Yogyakarta. Okay. So in this case, turned out that to achieve both of the delivery time minimization and also cost minimization, we only need to, and based on the scale of disaster, we only need to choose Jakarta and Surabaya as the supply node, with Cilacap, Surakarta, and Semarang as the logistic, as the LOA, yeah. So as the logistic operational area. Okay, so it means that should we use the other nodes? Yes, if it's possible, we might still need to use it. However, the biggest percentage is these three locations, which is Cilacap, Surakarta, and Semarang. Okay, Surakarta is located really close to Yogyakarta. It's not being affected by the disaster. It has the airport, but it doesn't have port. While in Cilacap, it has a direct connection actually from Jakarta to Yogyakarta. It has railway too. And so if the Yogyakarta as affected area is overwhelmed and the railway cannot be used directly from Jakarta to Yogyakarta, they still can stop in Cilacap, and there are plenty of routes from Jakarta to Cilacap until it can achieve Yogyakarta. As for Semarang, aside from airport, railway, Semarang also have port, which is really good, and it's actually located above the Yogyakarta, so that all the supply came from Jakarta and Surabaya can be sent through Semarang. Okay. And this is actually the result. This is the goods distributed by percentage, yeah, for each node for the Yogyakarta earthquake scenario. Okay, so we have the biggest is the Semarang, and then Cilacap, and then Surakarta. But then we also use Malang, and still quite high, 15% from all the supply node come from Surabaya. While the others, such as Magetan, Cirebon, and Tasik, is quite small percentage. It can be happen due to the lack of the airport first, and the capacity itself is small, and probably the location itself or the node capacity and link capacity is not as high. Okay, so how is the result for the transport mode? So for the from the supply node to LOA or logistic operational area, we actually at the beginning we actually use a lot of airplane, which basically during the initial period 1, 2 and 3, we used a lot of airplane, which is 46.8, and then we also consider the use of the truck, which is 45.9%. Okay. And for supply to logistic operational area, there is no need to use the helicopter, as it's actually quite far from the supply node to logistic operational area. It's not the fastest, it's not the biggest too, but it's the most expensive one. But we consider the use of helicopter from the LOA from Surakarta to Yogyakarta about 5.7%. Okay. And we also use the vessel to send the goods. This good is mostly from Jakarta and Surabaya, and then they send it to Semarang. And from Semarang, there is a high possibility that the goods is being sent by truck, because from Semarang to Yogyakarta, it's actually only take 3 until 4 hours. So it should be okay. And based on this result, actually, what we can say is actually if during the period 1, the number of the supply is the highest, so we need to send and since we need to send all of the goods, the vessel is being used. Obviously, even if the vessel is being used, from the supply node to the logistic operational area, it will take a longer time, and most of the time the goods will be received probably in period 2 or at the beginning of period 3, because we have in each period we have 3 days. Yes. And airplanes and truck basically dominating, or the mobilization, mostly the airplane is dominating from the first level, and the truck is dominating the second level from the LOA to the affected area. Okay. And since I mentioned before, since helicopter can be used for relatively short distance, this 5.7% is actually to deliver the goods quite fast from Surakarta to Yogyakarta. Okay, and then the choice of the mode itself also happened because we basically limit the number of this transportation mode. Okay, if we allow the number of unmet demand, and then we only have a limited number of airplane, for example, obviously the percentage of the unmet demand will be high. Okay, and if we consider the truck too, we can actually reduce the unmet demand quite big since period 3, and then we will have no unmet demand if we still keep utilizing the truck. However, obviously a really high number of supply, while not being proportioned with the number of the vehicle or a certain transport mode, will force the government or decision maker to basically use the biggest capacity vehicle, which is vessel, even if the the travel time is quite slow. And again, if we can use the vessel, we actually can minimize and probably will not have unmet demand at all. Okay, although in this case, because one period is actually 3 days, so if we check in a multi-period, then probably using vessel will also resulted in unmet demand for each period of or hourly situation. Okay, and if we compare to the cost, obviously, the these costs using the vessels will be in will basically just give a slight increasement of the cost, or you pay more because you use the vessel, and the use of truck with airplane is also will cost you more. However, the increasement is not as much. And if we want to consider, okay, I want during the first trip period, actually you really want the suffering people to receive the goods as possible, so that rather than having unmet demand, it's better that you pay more or you spend more cost later after a certain period, the initial period, then probably we can move the objective to the cost itself. Okay, now what will be the result if after a certain period, then we will have additional link open. The link here is that you don't require to go to logistic operational area, but you can send the goods directly from the supply node to the affected area. Actually, if we compare the base model with the hub network, or DLA with the modified model with mixed network, for the basically for the first 3 period, it really it's basically the best if we consider with the hub network. This happened because for example, in the first 2 period, the airport in Yogyakarta cannot be used in this scenario. So all of the goods that is being sent from Jakarta needs to be sent through the truck, using the truck. And after certain period of time, after the 3rd period, actually having the mixed network, it means you consider use the hub, but you also have the direct relief distribution directly from the supply node to the affected area, will also give you a minimum time, delivery time, and also the minimum cost. So in this case, it means that when we generate this scenario, we can actually give this result to the government and say, okay, during the first 3 periods, so it means that within probably the first week, it's better if we have the logistic operational area, we have the hub first. Okay, so if there is a chaos, it's not going to be in the affected area. Then after a week, then probably everything is settled. The number of the demand, the number of supply is becoming more constant. Then we can move and then basically send the goods directly to the affected area. And within those first 3 period, all of the infrastructure breakdown can also be fixed, and that will basically allow the government or the agency to send the goods directly. Okay, so from there, actually, we already arrive in the conclusion. So basically, the breakdown obviously is not something uncommon during the disaster, and basically whenever we have the disaster, whether we're ready or not, we might face several limitations, including the transportation resource, the infrastructure breakdowns, and we also expect that the supply that we have and the demand that we have will be uncertain. In this case, I model it as the time varying. So each period you have a certain supply and demand. And then it's better if we when we develop the model, we can also consider the multi-trip situation, As why, because for example, you have 72 hours and then you have only two airplanes. If you don't consider the multi-trip, then you can only have two trips, yeah, per this period. So that's why I consider the multi-trips. And it's really important actually for the government to start assess their logistic capability, including their alternative for the important nodes, for the important links. And if it's possible, they also make the alternative to be more agile, to be more flexible whenever the disaster happen. Then we can always have these alternative nodes. And actually, for future research, because we only consider one scenario with the same, almost the same magnitude actually as the previous one. Uh, so if the multidisciplinary study is possible, we actually can ask the help from geologists probably to build the scenario, probably with the probability also. And so we can develop from solving it deterministic like this into more the stochastic programming where we have several scenarios. And sometimes a different disaster might also happen. And for example, whenever we have a volcano's eruption, and then we will avoid the use of airlift or airplane or helicopter as much as possible due to the high quantity of the ashes that might give another risk to the agency. Okay, so up until here, that's all actually from me, but maybe we can have a more discussion, yeah, rather than me giving you lecture. I think it's really important if we do have discussion. Okay, thank you, Pak Wira. Time, I will return the time to you. Okay.
Okay, thank you, Dr. May. I think I will stop the recording first.
Okay.